Welcome to this explainer. Today, we're going to absolutely demystify Java design patterns and turn what is usually a massive study headache into a perfectly prioritized playbook for your next senior or engineering manager interview. Seriously, if you've ever just stared at a giant wall of software architecture concepts and wondered, where do I even begin? Well, you are in the exact right place. But before we really get into it, I want you to ask yourself honestly, are you genuinely prepared to answer high-stakes architectural questions under pressure? Like when a hiring manager asks you to design a robust, scalable system right there on a whiteboard, can you confidently reach for the exact right design pattern? Or do you kind of find yourself defaulting to messy, tightly coupled code? Yeah, we've all been there. But today we're changing the game. Okay, let's take a quick look at our roadmap. We're going to cover 1. Your interview cheat sheet. 2. Tier 1, the essentials. 3. Tier 2, flow control. 4. Tier 3, the specialties. And finally, number 5, acing your next interview. Section 1, your interview cheat sheet. So this ultimate priority list is a total lifesaver because it completely removes the guesswork. It ranks these patterns from the 5-star, absolutely critical essentials all the way down to the nice-to-haves. Look, when you're preparing for a senior role, you do not need to memorize every single pattern ever created. No way. You just need to know the ones that actually power real enterprise applications. So consider this cheat sheet your new best friend. It highlights exactly where you should be spending your limited study time. Section 2, Tier 1, the essentials. We're kicking things off with the Singleton. This is an incredibly popular creational pattern, and it's designed to guarantee that a class has one, and literally only one, instance throughout your entire application. The absolutely crucial point here is that it avoids expensive, repeated object creation. So whenever you need a single source of truth, or if creating an object is just massively resource-intensive, the Singleton is your absolute go-to solution. And you know what? You're likely already using this pattern every single day in production frameworks without even realizing it. This is especially true if you rely on Spring Beans. Just think about your database connection pools, or your application's configuration managers, or even the loggers recording your system events. It would be a huge waste of memory to create a brand new logger object every single time you wanted to write a simple debug line, right? Well, that right there is the pure power of the Singleton in the wild. Now, a classic config manager Singleton uses a private constructor and a static final instance to completely lock down object creation. By making that constructor private, you are physically preventing other classes from using the new keyword to spawn unauthorized copies. Instead, they have to call the getInstance method, and that method hands over that one single shared object. Simple, but super effective. Next up in our Tier 1 heavy hitters is the factory pattern. You can think of this as a centralized manufacturing plant for your objects. Rather than a client class explicitly calling a constructor to make an object itself, it just asks the factory to do it. The factory then takes a look at the parameters, makes the call, and decides exactly which subclass to instantiate and return. By comparing these two approaches side by side, we can see exactly how the factory pattern removes all that messy conditional logic from your core business code. Without it, man, you end up with massive, ugly if-else blocks scattered everywhere just to figure out what type of object to build. With the factory, your code actually adheres to the open-closed principle. This means you can introduce brand new object types into your system without ever touching the existing business logic. You just update the factory. It's a real game changer. And hey, when an interviewer asks where you've seen this in the real world, point them straight to Spring's application context, or even standard logger factories. Spring uses the factory pattern extensively behind the scenes to manage and dispense your beans based on your configuration. Proving to an interviewer that you don't just know the code, but you actually know how your favorite framework utilizes that code under the hood, that is an instant way to stand out. All right, the final Tier 1 pattern is the builder. This one is going to be your best friend when you're dealing with objects that require a massive list of parameters. Because we've all seen those terrible, giant constructors that take like 10 different strings and 5 integers, right? It's a nightmare. The builder pattern swoops in and separates all that construction logic, letting you configure an object step by step before finally putting the whole shebang together. So instead of a huge, totally unreadable constructor, the builder pattern lets you chain methods together to create highly readable, immutable objects. It's actually very similar to how the popular Lombok library operates. You literally just call .name, .age, .salary, and then .build. It is beautifully clean, it makes your code incredibly easy to read, and it ensures thread safety because the resulting object can be completely immutable. Section 3. Tier 2. Flow control. Now we're moving into managing requests. I want you to think of the chain of responsibility pattern as a sequence of steps, kind of like a relay race. A request comes in, and each handler gets a chance to look at it. If the first handler, let's say it's an authentication filter, approves the request, it passes the baton to the next step. But if it fails, the chain is broken right there and the request is rejected immediately. If you have ever configured Spring's security filters to process incoming web requests, guess what? You've already mastered the real-world application of this pattern. A browser sends a request, it hits the authentication filter, then the JWT filter, then the authorization checks, and only after all of that does it finally reach your controller. It's honestly just an incredibly elegant way to completely decouple your security checks from your core business logic. Also, sitting here in Tier 2 is the command pattern. This one encapsulates a request as an object, which makes it incredibly useful for scheduling tasks or implementing undo functionality. By turning a simple request into a standalone object, you can pass it around, put it in a queue, delay its execution, or even reverse it. Fun fact, every single time you submit a runnable task to a threatful executor in Java, you are utilizing a variation of the command pattern. Section 4. Tier 3. The specialties. First up in this tier, we have the abstract factory. Now, the abstract factory simply scales up the standard factory pattern we looked at earlier. It allows you to swap out entire families of objects seamlessly. Imagine you're building the UI that needs to look native on both Windows and Mac. An abstract factory ensures that if you request a button and a checkbox, you get a Windows button and a Windows checkbox together, completely preventing any mismatched components. It's absolutely fantastic for swapping out entire database providers or cloud environments at the enterprise level. Then there's the prototype pattern, which allows you to clone a heavy, say, 100 megabyte object rather than building it from scratch every single time. Seriously, if you have a massive configuration object, a highly complex game character, or a loaded deep learning model that takes immense CPU cycles to generate, you absolutely do not want to use the new keyword to build a second one. You just implement the prototype pattern to clone the exact state of the original. It saves huge amounts of time and system resources. Finally, we have the iterator pattern. This provides a standard way to traverse elements, and it is baked right into the DNA of standard Java collections. Whether you're looping through an array list, a hash map, or a hash set, the iterator pattern completely abstracts away the underlying data structure. It gives you a unified, totally safe way to move from one item to the next. Section 5. Acing your next interview. So here is the absolute most crucial point of this whole explainer. Interviewers don't just want textbook definitions. They want to hear exactly how you apply these concepts in production using frameworks like Spring and Spring Security. Because look, anyone can memorize the definition of a singleton, but a true senior engineer, they can explain why Spring uses singletons for its beans by default and how that impacts thread safety and application memory. Connecting the pattern directly to the framework is the real key to passing the interview. I'm going to leave you with this one thought. Take a look at your own code today. Identify just one of these hidden patterns, and I promise you'll be perfectly armed for your next big interview. Are you relying on builders for your data transfer objects? Are you using factories for your logging? Find those patterns in your daily work, understand exactly why they're there, and you will never struggle with an architecture interview again. Thanks so much for joining me on this explainer, and happy coding.